Good afternoon, everybody, and welcome to today's webinar brought to you by PARC is in the business of breakthroughs, practicing open innovation to provide custom R&D services, technology, expertise, best practices, and intellectual property to companies worldwide. NineSigma is proud to work with PARC to bring you a gallery on our 9Sites platform where you can view and directly engage PARC on any of the technologies present on that site. For more information on any of that, please visit the PARC Gallery at our 9Sites website or visit the PARC website at www.parc.com. So today, Mike Furst, Director of PARC's Video and Image Analytics Lab, will be presenting video and image analytics, a key part of an analytics strategy. In just a few moments, I'll let Mike take the floor and present all the fascinating abilities of this technology. But just a few housekeeping notes before we start. If you have any questions during the session, please at any time submit your questions to the Q&A chat box in your dashboard. We will be collecting these questions during the entire webinar, and then PARC will follow up with you directly after this webinar. But should we have time at the end of the webinar, we may be able to answer those questions live. Additionally, I wish to inform all of you listening live that this webinar is being recorded, and the content will be made available after the webinar to view at a later date. So without further hesitation, let me present Mike. Mike, go ahead.
Hi, this is Mike Furst. Thanks for joining today. I'm excited to talk about an area where here at PARC we're working every day. So I hope you come away with both some new facts and interested in the possibilities and excited about exploring it further. So a couple quick words about PARC to put this presentation in context. PARC's an innovation partner for companies and government agencies of many types. PARC provides breakthrough innovation as an end-to-end service from problem to prototype. We do ideation. PARC can invent together with you, focused on your problem, producing novel and customized technological solutions for your strategic needs. We help articulate a vision and a roadmap. We've helped clients explore various technological options for their business and how to get there from here. We also thrive on technology creation and development. Our core competencies are deep technical expertise. We apply ongoing research to the cutting edge to invent and prototype custom solutions. And we can also transfer IP and know-how to your team as part of that process. As such, PARC's in the business of breakthroughs. It has been for 45 years. It was originally founded as Xerox PARC in 1970 when we were charged with the future. That led to many inventions. A bunch of them are shown here, including the PC, but more importantly, when combined with the others of laser printing, the graphical user interface, networking, which enabled distributed data sharing and moved the information across people and devices, and the approach of social science used in technology design to understand what technology is fit for purpose, to engage the user and get the technology right for the job. We've done this for years with Xerox, but in 2002, we were incorporated as an independent company, which allowed us to do research for a broader set of client base, and it's really broadened the potential areas of impact that we followed, many of which are shown on the bottom row of this slide. And it's also about a new business model for innovation. Now today we work in many domains. 6 are sort of highlighted here as some of our key focus areas. They range from new materials and the new device and the way that manufacturing gets done, to reinventing all the ways these new and existing connected systems communicate with content-centric networking, which is aimed at making the network more secure, flexible, and scalable, to the use of all the data generated by these systems and devices connected in the world today in various forms of analytics, to put it to work to solve today's toughest problems. So today, I'm going to focus on the area that my particular lab focuses on, which is in the video analytics space, and how we can put that to work to enable breakthroughs. So for today, here's my 3 topics. First, a little bit about video and image analytics and how it will be a major part of any big data analytics strategy. And video and imagery are perfect complements to the more traditional data analytics that people might be thinking of when they hear big data. An image's unique attributes and rich content can enable very powerful insights if you know how to extract them. Next, we'll share some real projects for real clients and discuss real-world challenges that we've faced or that you will face as you get into this in doing so. And as with any challenge, having a good toolbox and knowing how to choose and use the right tool for the job is a critical factor in project success. So we'll spend a little bit of time on that. And then finally, we'll wrap up with how to get started and perhaps how PARC can help in that process. So big data. Big data is a broad term used for innovations of all kinds today. It's a broad term used to describe data sets now available that are too big for traditional approaches of data mining. Big data is transforming the world in all kinds of ways. At PARC, we believe the potential applications for video and image analytics span a broad range of industries, with data from surveillance cameras to cell phones. The range and volume of this content is increasing exponentially and will soon dominate many other forms. For example, in healthcare, the quality of care versus the cost of providing it represents an ongoing struggle. What if video analytics could provide healthcare delivery while reducing costs by augmenting the reach of human interaction without increasing the cost of labor? Cameras in patient rooms can augment the attention of floor nurses, letting them know when someone looks uncomfortable or in need of help. Instead of a 24/7 nurse at home for healthcare, video analytics system could monitor patients' well-being for a portion of the day. Do they fall? Are they eating properly? Are they taking medicine on schedule? How's their behavior changed over time? Or perhaps in a municipality concerned with congestion, the environment, and the well-being of the constituents, you could go beyond simple sensors like ground loops and parking sensors that simply indicate a vehicle's presence, and go beyond surveillance footage that's gathered and stored and not referred to until after an incident is reported to something more. Increasingly, video will play a role in smart cities by capturing the flow of passengers and pedestrians versus just vehicles. Dynamic speed limits will adjust to crowds. Traffic analysis will be used to eliminate congestion through traffic light optimization and smart parking. Safety will improve by identifying patterns that lead to accidents. Computers will scour the video inputs and provide screened recommendations to what a public safety officer should take a detailed look at, saving time, reducing fatigue, and improving the quality of life in a city. In other settings like education, video analytics can augment what a teacher already sees and can focus on each day and focus on every student throughout the day. It can provide insights into who's involved and doing well, who's engaged in the learning activity, or perhaps be an early warning system for teachers that a student's having trouble, losing focus, or getting bored. These additional behavioral insights can complement the data from assessments and testing to quickly help the teacher personalize tomorrow's educational content for each student every day. Finally, in retail, today we derive insights from the point of sale transactions. A grocery store loyalty card tells us what people buy and when. But video analytics can capture the customer experience. How do people move throughout the store? What items do they pick up? What do they compare? How do they interact with the sample stations? How long do they wait in line? Video analytics systems combined with transaction data provides a dashboard of valuable insights, including comparative data from other store locations that enable managers to optimize store design, product placement. Shoppers who wish to be recognized may enjoy a personalized experience with recommendations and reminders tailored to them. So we see video and images as the other big data. Overall, video analytics completes the picture of an individual or business process and can be instrumental in instrumenting the uninstrumentable. Computational analytics tends to utilize data that is structured, specific, and transaction-oriented, designed for a purpose with clear definitions. Video is a great complement. It can fit many needs and is almost universal in terms of application space. It's very rich in content. A picture is worth 1,000 words, and each frame in video multiplies that value. Video could be captured and processed to extract one kind of output today, but then in the future, new questions could arise and the same video re-examined and new insights learned. It's also growing at tremendous rates. In 2013, it's reported that high-definition surveillance cameras produced 413 petabytes of data per day. That's the equivalent of 92 million DVDs worth of content each day. And it's expected to more than double to more than 800 petabytes per day in 2017. To build on the retail example shown here, video can fill out many gaps in analytics, not just what you purchased or the coupons you used, but it can capture what you looked at, what you compared, were you shopping alone or with others, and more. All data that retailers desperately want. So what makes up video and image analytics? Video and image analytics can be described in several layers of capability that I've shown here, building up from fundamental scene analysis, people and behavior analysis, up to a semantic understanding of people and scenes. Cameras capture the world through their optics and change the light into ones and zeros. Those digital eyes provide the raw material for a fundamental layer of video analytics to go to work on. These fundamentals include the recognition of objects, events, and images, and extracting important signals, either visible or invisible, from the subtle differences frame to frame in a video. These end up being the basic building blocks. They're useful on their own in many applications, but they find even more use in the next level, which we're calling scene analysis. This includes tracking and timing of events and objects, so how they interact with each other, the sequence of events, understanding this variation in timing between them, and this becomes the heart of many operations-focused analytics projects for process improvement. It provides rich data that would be difficult to instrument with unique sensors or tedious or expensive for people to capture manually. It also includes identifying something out of the ordinary or an anomaly. In many cases, it's these unexpected events that can be much more important than the common ones. They're also much harder to teach a computer to find, but are key in the scene analysis layer of video analytics. Eventually, we want to understand more about the scenes and the people and objects within them. This can lead to a better understanding of what is happening in a more human way, not just what humans are doing in the scene, but enabling computers to describe what they see in more human terms, leading to better, more appropriate action being taken as a result. It's not just the kind of processing that can be done that's important. Another option to think about is the way in which the data is captured. There are many options, but they largely fit into what I'm calling 3+1 categories. Of course, we're probably all familiar with the fixed camera systems. It's the traditional surveillance camera scenario. Field of view is steady, and items, people, objects move in and out of the scene. The background is typically constant. Beyond this, there are more and more mobile options that complement the fixed installations. Wearables like body cameras, GoPros, the new Microsoft HoloLens, which capture a view from the wearer's perspective and tend to be along for the ride, offer a different, more intimate perspective on a scene and have their own strengths and weaknesses versus the fixed cameras. Another option for gathering data is the mobile platform that's essentially a roving set of eyes on the scene. Cameras that fall into this category are your smartphone or even UAVs or other vehicle-mounted systems. They can be used to gain unique vantage point a person might not easily be able to get to, or a fixed camera may have occlusions that block it from seeing. The last important perspective in the capture side of the video analytics is the +1, if you will. It is whether your analytics team will use isolated cameras doing their own analytics separately and unaware of other information, or will the system be designed to have cameras work together as part of a more comprehensive network, getting a bigger perspective on the scene. Each of these has their own pluses and minuses, and as one moves from explore to delivery of a solution, it becomes more important to know how each can be used to develop an overall effective result. This leads to a set of technical challenges to be navigated when thinking about video analytics. Algorithms and cameras that I just described are the starting point, but there are some additional items to be considered. First is the choice of technology and the system architecture. As I mentioned, there are many approaches to video and image analytics. The area is hot, and many new technical options are being developed and made available every day. The state of the art is advancing daily. For example, a recent computer vision and pattern recognition conference in Boston, CVPR 2015, a couple weeks ago, was one of the biggest and spanned a week of tutorials, posters, and presentations from a worldwide set of contributors, all sharing reviewed and vetted approaches to teaching computers to see and understand videos and images. Keeping up with the technology can be a job on its own and is needed to make good design decisions when thinking about the application of the technology. Another decision to be made is where the analytics will be performed. Do you do it out near the cameras or on the mobile devices on the edge of the network so that less data needs to be shipped around the system? Where do you store the data in that case? Does it make sense to ship everything back to a central location for mining there with more powerful computing platforms? Next, the world is a really messy place. Developing a system to work in the wild versus in a laboratory setting can be a challenging activity. Simply put, how do you get performance in the face of all kinds of noises? Some of these include lighting. Are there shadows, glare from the sun, differences between morning and afternoon, reflections, stray light, seasonal changes in how the scene is lit? Or does weather affect it? Snow, fog, rain, puddles on the street, mist or downpours. Movements in the platform itself, the camera, vibration, drift of the field of view over time, or contamination in dirt, slowly degrading the view from the cameras. Is the pose of the items of interest, is it face on, side view? And how accurately is the current scenario to ones that you've seen before? No two sites are the same. Backgrounds, configuration, and installation variability all contribute to variation that systems need to be robust to. Think about tracking a vehicle down a street throughout the year and all the variability that we can deal with as humans. You'll see that as a car driving down the street. But teaching a computer to do that amongst all those noises is not as easy. Performance and accuracy is also critical for such systems. This is particularly true where more automation, scale, and volume of transactions are the norm. Take a tolling system in a big city, for example. Manhattan has about 1.6 million commuters. Statistics show that about 160K drive from Brooklyn alone or through Brooklyn on their way into commuting. Let's say about a quarter of the overall commuters drive in across any or all the bridges. If only a 3-sigma performance on your automation or 93% accuracy rate, that would leave you with 66,000 defects in your reads. Defects per million, or in our case with this scale, it would be about 26,000 bad reads per day. In order to get to a more workable level for the kind of automation that many clients are looking for, the level of performance needs to be well above the 99+% accuracy in order to get there. 5 sigma being about 93 bad reads in our case, for example, 99.97% accurate. That's a tough performance level, and way beyond that of many of the off-the-shelf technologies are capable of without special tuning and thought put into how the system will work in the environment that you find it. One option to consider is to determine when and how humans collaborate with computers and in the operation of the system and the solution, the so-called sort of human-in-the-loop systems. This is a collaborative system using computers for what they're good at, scale, speed, precision, and people for what they're good at, creativity, problem formulation, intuition, action planning, cross-domain recognition of objects and characters. Humans can guide the attention of the computer to get quantified results and detailed measurements of systems that the computers can identify quicker, or humans can assist the automated systems with particularly tough problem sets that the computer flags as requiring human intervention. The key is to develop systems where the computer screens most of the inputs and only passes along what it's not confident of to the computer for expert review. And finally, one more category to consider is the real-time nature of the desired solution. Many interesting concepts using video analytics require results very quickly so the action can be taken in a time frame suitable for the application. Is the result needed in the moment as a user interacts with the system in largely real time? Does it require feedback within a minute in order to send someone over to help in a retail establishment? Or is it analytics on store operations to be reviewed at the end of the day or before the weekend? All of these criteria or requirements affect your decisions on your system design. So sorting out all these possibilities and options is a challenge. We have clients that come to us in all different places in this process. We like to begin with a focused deep dive to understand the challenge at hand, to identify the opportunity, assess options, and because this field is moving rapidly and others are rolling out video and image analytics, it's always good to jumpstart the learning process with some benchmarking of other solutions that are available. We then understand and follow an iterative approach and do a quick proof of concept to determine and understand the opportunity, the needs, and whether a proposed solution can hit the desired business impact. The next steps beyond that are working with the client to demonstrate, deliver, and scale this solution. We found this approach to help navigate through all the options that we were just talking about, effective and a nice structured way to do this. So I want to transition now to talking about some examples of some of the innovations that we've seen most recently and participated in the application of image and video analytics to real-world problems. The examples are going to span from concept to transfer, through the workshop phase, through execution of a proof of concept, and beyond. In particular place to start is in transportation, some example transportation areas where we've worked with industry from top to bottom for our clients. Transportation video analytics addresses many market needs. We've learned a lot about the needs of the populace and the municipalities and local governments and transportation system providers that serve them. Many of the opportunities we've discussed with them lend themselves to the use of video and imagery as a robust and flexible source of information about what's happening. Society in general needs to address several grand challenges. Congestion, environmental impact of human activity are two of the largest. But they sort of fit into some major categories of efficiency, safety and security, and predictability. All are very important to this domain, but also have many attributes common with needs from other domains as well that we'll soon talk about. So to be specific with a particular example, with an eye on improving traffic flow while continuing to use tolling to fund roadway maintenance, many operating agencies are looking to go to open road, transponderless, all video-based tolling systems. In addition, all video-based tolling enables interoperability between various tolling agencies because there's no customized hardware to deploy to vehicles or to infrastructure along the road. Transponderless video tolling can be a great solution, but requires new levels of accuracy in the automated license plate recognition system. Currently, people are often employed to read a plate from a captured image if for some reason this transponder doesn't work. This fail-safe system, this human-in-the-loop system, while effective, won't scale effectively to the volumes needed to be successful if all of the reads were done with an image or with video. So we worked with a client to enable an all video-based tolling at levels of accuracy where the human reviews drops to or below the current operating levels with transponders as the primary reading mechanism. This enabled the kind of scale needed for this application to be broadly employed. PARC works from concept through delivery in partnership with the client in this case. So the challenges, some of which are shown here a little bit, of hundreds of license plate designs growing every year. The U.S. is particularly challenging with its variety and customization of license plates. There's all kinds of environmental conditions. Some examples of variation are sort of shown over here on the right: lighting, pose, shadows, dirt, and the accuracy required, which mentioned a little bit in the tolling example about New York City. The level required is quite high, 99 plus yield at high accuracy before engaging a human to approach things. So we took a couple of unique approaches in working through all the choices. One of them is incorporating the plate rules. There are formulas and ways that certain numbers follow certain letters in patterns, which you can use as visual cues to help understand the plate you're looking at. We also used synthetic training data to speed the scaling and adaptation to the new plates from various states. Machine learning technologies employ a wide variety of learning mechanisms to teach the computer what it's seeing, and synthetic data allows us to speed that up. We, of course, continue to leverage human in the loop to reach the performance levels we want. And we design in feedback as the system operates to improve it over time. Right now, the system is deployed, reading millions of plates a month and achieving a 99+% accuracy at 80% automation levels, which makes it one of the leading offerings in this space. Small video shown here about finding the license plate, reading it, digesting it, and making reads is shown here. So another quick topic in transportation, congestion and effective managed lanes can improve overall traffic flow. Congestion is a major concern and the economic impacts are significant. High occupancy vehicle lanes are put in place to reward those who can transport several people in a vehicle at a time. However, they can go underutilized, and agencies have been converting the HOV lanes, high occupancy vehicle lanes, to high occupancy tolling lanes. The intent is to allow anyone to drive in the HOT lane, but at a price. With 2 or more people, you drive for free. If you're by yourself, you pay a toll. These are currently operated using a combination of transponder settings indicating the number of passengers currently in the car and employ roadside enforcement. These have proven challenging to operate due to the difficulty enforcing tolling and the self-reporting of riders. Compliance varies by time of day and traffic conditions, and enforcement is time-consuming. In addition, drivers are paying a toll based on an agreement that the agency running the road will ensure a certain minimum speed will be maintained in the lane. This challenges many agencies to have better data in order to show that they are meeting that minimum speed requirement. Otherwise, they'll be unable to continue as an HOT lane. The application of video analytics to count passengers and enable robust tolling and provide an early warning for enforcement has become the strategy. You can imagine if you're looking at a vehicle going by at highway speeds many times a day and under many weather conditions, choosing the right combination of technologies will be critical. So some of the challenges are listed here, similar in terms of lighting environment, passenger compartment illumination, looking into the front of the car. What you see here are a set of images of the front view of cars that were captured. The windscreen was localized, the passenger seat was looked at, and a set that are characterized as being occupied and a set that are being characterized as unoccupied. For example, you can see some highlighted examples of a person almost entirely occluded by a newspaper, but still able to be characterized as occupied, and one with a small dog sitting in the passenger seat. The system trained well enough to understand that that's not a qualified rider in the front of the car. This system is currently achieving about 96% accuracy in automatically determining HOV +2 violators and enabling enforcement with minimal review of the violation. So moving on quickly to a couple other examples. In retail, we are working with clients, again, throughout the pipeline, but I'll talk about one that's more in the proof of concept phase. In retail, video analytics has many places where it can be effective in that market segment, from operational effectiveness in terms of running the business better, to helping understand the situation going on in the retail establishment to help associates get the right information at the right time to the guests, and in particular, the connecting of clicks and bricks, perhaps one of the most important areas. With online shopping, a retailer knows almost everything about you and what you looked at in their store. They know what you looked at, what you put in your basket, what you removed, how long you spent on each item. But contrast that with what they have about your in-store experience. They know what you purchased, and that maybe you used a coupon, but that might be about it. Video analytics is a powerful way to instrument a physical store and understand much more about the guest journey and their total experience, their behaviors, interaction with products, interaction with signage, and the effectiveness of smart signage. Video and image content, therefore, is a powerful addition to other sources of information the retailer has about their guests and can drive valuable insights from that data, leading to action. As an example, a client was interested in gathering an operational performance data to drive productivity in a quick service restaurant. There was, of course, info from the point of sale system, as I mentioned before, but that didn't provide the complete picture. Since the desired timing info can be gathered by someone in the store visually assessing the operations and taking notes, that kind of an operation is a great candidate for automated video analytics from the in-store cameras. So this quick little video that I'm going to run here in a second shows a good example of the combination of a person re-identification, tracking, and timing linked with event detection. What you'll see is that in step one, this particular guest has been tagged as having placed an order. In step two, you'll see him standing over here on the side, waiting for his food to arrive while others pick up their items and move about the environment. Eventually, his item comes up. He walks over to the counter to get his food, and the event is recognized of him coming up, and the event of taking the tray is recognized. The timing information is then generated. So here you can see him standing here. Eventually, it becomes his turn. His tray pops up. He recognizes it. He walks over. We have re-identified that it's the same person. We've seen the event of gathering the tray and been able to capture the time that elapsed between those various events. This is a retail example shown here, but it could be any kind of queue management or process timing application. It could be parking management, manufacturing processes, safety, or security applications. This data would then be used in combination with other data from retailers to complete the operational dashboards that they can use to run their establishment better. Extensions of that include the use of video analytics to determine the number of operational and strategic decisions that need to be pursued every day. For example, it's possible to gather not only where in the store did individuals go, but how long they spent there, what they looked at. And video and image analytics can provide a lot of the missing information to complete the clicks to bricks picture, enabling a more optimized retail experience. One example from Xerox that I will include here real quickly. Of course, we're delivering technology to Xerox, and much the same approach and success there as well. So I'll show another example that emphasizes the application of video and image analytics on the edge of the network, customized for use on a smartphone, and sort of all that implies. So Safe Courier is an application designed to automate paperwork transactions, in this case for an insurer. What it includes is the ability to capture documents, photos of the damage, combine them together in a way that automatically allows them to be submitted versus putting them in the mail in some kind of hard copy way, which was the previous approach. As the app is kicked off, the user simply holds the phone over the documents to be captured. And you can see it starting right here. We'll take a look. We'll submit a new claim and get the process started. So going from a very manual process and hard copy mail to making it all work seamlessly on a smartphone. So the user will simply hold the phone over the documents. The system will do the video analytics to determine when the picture should be taken to get a great position for capture. It automatically recognizes the document, finds the edges, adjusts for distortions, and prepares it for sending so that it can be used downstream. This whole process enables great business process outsourcing back office work because we're ensuring that the content going into the process is suitable for work in the back office when it gets there. All the other information was captured, cleaned up, and attached, and a complete quality submission can be done in minutes with this app, and the user experience is quite simple. Because of the automation around the video in real time, locally on the smartphone, it made that process very, very simple. Some quick overview of some exploratory directions that we're taking in healthcare and the industrial market segments, more at the workshop level, although we are working with clients, again, throughout this space. When it comes right down to it, there are basically two major goals of the healthcare system: deliver excellent healthcare outcomes and do it at a reasonable cost. And so video and image analytics shows great promise in enabling new ways of capturing ongoing health status and longitudinal data. When a computer can become many additional eyes for the doctors and nurses, especially when the content is distilled effectively for them, it allows them to take action as needed when the time is right. This can be in a clinic, in a nursing home, or even in a hospital, or even better, in a patient's home where they can be comfortable living at a lower cost with a higher morale, but still remain very connected and monitored by professionals. Since cameras and computers can extract information from video that is much more subtle than a human eye and brain can, there's an opportunity to gather richer information in new ways. The vital signs can be monitored at any time throughout the day, which can provide a more continuous look at a patient than is possible during the typical 20-minute office visit that occurs once in a while. In addition, themes repeat themselves from other domains as well. Safety and security monitoring process steps to ensure compliance, like safe hand washing or surgery prep workflows, are all possibilities. There are many, many possibilities to explore this application of video analytics in healthcare, and we're exploring a variety of those in the domains shown here with various clients. In the industrial segment, similar operational and safety goals are very aligned with what's possible now and in the future. Again, the areas of people and object tracking and timing for process improvement come up here quite strongly. But also ensuring human safety is a big theme. There's a desire to put in place systems that monitor video feeds and provide feedback to the individuals involved, as well as to the central management site for coaching and feedback. It can be applied to monitoring operations and to watch out for workers who are alone in isolated areas. And it can also apply to health and safety policies. Are they being followed? Is everybody wearing a helmet? Was there unauthorized access to secure location? And all of these are very amenable to video analytics of various kinds. So getting started. How do you get started in this space? Of course, we feel the best place to start is with the kinds of questions we address in the initial exploratory workshop. In particular, the definition of the opportunity and a clear definition of the business outcomes, the business impact should be articulated. The rest of the steps follow naturally when supported by the right toolbox and team. So from our experience, we'd recommend a toolbox that has the following kinds of content: access to and an understanding of the range of video and image analytics algorithms and architectural options that can be explored. You need to know what the tools might be to be appropriate and where and how to look for them and how they work. We believe rapid prototyping is very important, as each solution can require unique customization, and nothing beats seeing a system working early in the development process to know if you're on track. This is particularly valuable in identifying those critical unknowns that can derail a project. Our experience also shows that the steps which follow the proof of concept and the validation of business impact are also very critical. This is where you should be working with the development and delivery team who understands the process for maturing a technology, understanding robust design, and the processes for the optimization of the solution. And finally, experience with deploying video and image analytics solutions to operating groups and all that is required to scale them effectively helps head off potential problems early on. With the right toolbox used by internal teams or with external partners, the outcomes really could be outstanding. PARC engages with many different industries and can help you explore your opportunities for using video and image analytics for your business. And some of the ones I covered are shown here, but we have clientele from across this wide range working through this process with us. Hopefully from this talk you've seen a bit of the toolbox employed in those real examples that I showed you, have ideas about how we might employ it together to navigate the landscape of the option space that could be involved in your video analytics opportunity in your business. So just sort of wrapping up, contact us. Let us know how we can help. Again, this is our business model. We do breakthrough innovation from problem to prototype. Some of the links are shown here to reach us, but either at parc.com or through the NineSites gallery on NineSigma. So please contact us. Let us know how we can help. Thanks for both your time and interest today, and best of luck with your future projects. So I think we have maybe a minute or two. I don't know if there are any questions lined up now, or we may just end here.
You know what, Mike? We have a number of questions. I think that it's probably best to wait until afterwards, just because in effort of time, I don't think we'd get through enough of them. So we'll go make sure that we can send all of those over to the PARC team, and you guys can follow up with everybody individually. So I just wanted to, again, reiterate our thanks to the audience for listening in this afternoon. I also want to thank Mike for his time and expertise. Like I said, we're going to go ahead and wrap up right now. And like Mike said, we want to encourage you to visit the PARC gallery on our NineSites website. The link is right there. And also visit the PARC website for any additional information you might have. And contact us, of course, through any of those means as well. I just want to make a quick reminder that this webinar was recorded and will be made available for viewing at a later date. Any questions you have based off of those later viewings, feel free again to contact us through any of those links that we have up there. So we have an additional, I will leave this up while we'll let everybody else go. I'll leave the webinar up for another 5 minutes or so, just to gather any additional last-minute inquiries we might have for the PARC team, so that they can answer them through follow-up after the fact. Again, thank you so much to everybody, and have a great afternoon.